Covalent bonds form when atoms share pairs of electrons to make a stable connection with a definite bond energy, while non-bonded interactions are weaker attractions or repulsions between separate molecules or parts of a molecule that do not involve sharing electrons or forming a fixed bond. Think of a covalent bond like two people holding hands tightly to move together, where the shared electrons are the hands that keep them linked, and breaking that hold takes noticeable force, because energy is stored in the bond. Non-bonded interactions are more like two people standing close enough to feel one another, maybe holding a light grip or just feeling a pull or push from a distance, and those feelings change more easily with distance, orientation, or the surrounding environment. Covalent bonds have specific lengths and angles that you can measure, and they determine the shape and stability of a molecule. Whereas non-bonded interactions, such as electrostatic attractions, hydrogen bonds, and van der Waals forces vary continuously with separation and are often much weaker. When chemists draw a molecule with lines between atoms, those lines represent covalent bonds, not the weaker non-bonded contacts that still influence how molecules fold, assemble, or react. Energy changes accompany making or breaking covalent bonds in chemical reactions, but changing non-bonded interactions usually involves much smaller energy shifts and often affects physical properties like boiling point, solubility, or molecular packing more than chemical reactivity. A common mistake is treating hydrogen bonds and strong electrostatic attractions as covalent bonds, because they can stabilize structures a lot. Remember, they do not involve sharing electrons and are generally weaker and more reversible. Another error is assuming all non-bonded interactions are negligible. They can collectively control shape and behavior, so account for them when predicting folding or interactions. A third misconception is thinking bond lines mean atoms are permanently fixed. Covalent bonds can break and reform during reactions, so consider both bond energies and reaction conditions when reasoning about changes. For more videos and resources on covalent bonds and non-bonded interactions, check out www.gumballdegree.com.